Hey, what's going on, guys? KumakiKenZ here. In this video we're gonna learn how to run a boot sector game. So first of all, let's figure out what the boot sector game is. So boot sector game is a computer game that runs without any software dependencies on a bare metal when your computer kind of boots. And obviously this regards to x86 architecture of the processors. So in this tutorial, we're gonna download this TetrOS, which is the bootable Tetris clone, and we're gonna assemble it and first run in the online emulator, and then we'll run it. We'll write this to the flash drive and try to boot on the real hardware to see how it works. So all the steps that we would be doing in this video are absolutely essential for working with a bare metal. We're not going to be touching assembly on its own, but the environment to work with, the NASM assembler, which is absolutely essential to consider, is something that we're supposed to be having a look at this video. So another few words. So I'm on Linux, and the techniques that I'm going to be using are Linux techniques. So I'm going to be relying on dd command, and in the later tutorials I'm going to be relying on cat command as well. But if you're on Windows, you still can follow, because it's not really that much the matter of the operating system. It just seems to be more like a handy way to do this on Linux, and just I'm a Linux junkie, so just I hope you understand this. But anyway, the idea is to have a crystal clear understanding of what in particular we're doing in order to make this work. So this is also reproducible on Windows, but there are some problems, let's say. So as far as I'm aware, NASM can't be run directly natively on Windows. I might be wrong, please correct me if I'm wrong, but I found this guide on how to run NASM on Windows. So for those who is on Windows, this is possible using the DOS box. And I'm not sure, probably there is a different version of the NASM, since the DOS box emulates the DOS. But anyway, it would be possible to obtain the binary executable. It's not, it is executable, but it's just the bare command being assembled and turned into the machine code. But the output would be the same, I believe, whether it runs under the DOS box or if it runs on the Linux natively. And again, I think it's not possible to use another assembler because the current game is written using NASM, and I would say that most of the game, actually all the games I've seen, are written using NASM assembler because it's free, and I believe open source as well. Correct me if I'm wrong. If I'm wrong, please. So that's pretty it. Okay, guys, so let's go step by step, and I just want to copy the code. No, probably I don't even let me just download let me just download this stuff, and just want to give you an idea of the steps that you might have been considered, but this didn't really lead to a success potentially. So if I go to my downloads, and let's just extract the files here, delete, and the most natural thing to consider is try to grab this kind of image file and load it into online emulator for x86 platforms. So let's try to do so. By the way, I didn't even try this, but I believe this is not going to be working because of the size of this image. By the way, well, let's try the hard drive. Maybe it's gonna be working using the hard drive. I believe that might be possible as well. So okay, downloads, and this one, open and start emulation. Yeah, probably it's gonna be working assuming the hard drive, I believe. Might not be though. yeah, no bootable device. So yeah, it doesn't work. It doesn't work well here. And yeah, by the way, if we try it like to as the floppy, which in most cases it is assumed to be run as the floppy. Some guys provide the how to run this using the QEMU emulator, and it's suspected to be run like as a floppy image. So it's very something that is often has an often occurrence out there. So let's try this one, and here it would probably not even boot. All right, and yeah, it doesn't boot, and here is the error that we have, so unknown floppy size. And you might be wondering what to do next in this sort of a situation. So it's not the end, we can assemble it on our own. I have no idea, so probably the guy who wrote this TetrOS, probably didn't have these issues. Probably his emulator allows this like images. I don't know, but just if it doesn't work here, or if you just write this to the USB drive, it won't be working just out of the box. At least in my case, on my hardware. So if you have a look here, we have exactly 512 bytes, and properties like just tells the same. That's pretty it. And the way how I do this, I'm creating the image of 1.4 megabytes, just like the floppy image space. And I would still then I would write this to my USB drive, but that doesn't matter really at this point. That doesn't really matter that much. We can still use floppy images and write them to USB drive, and it's still gonna be working. So what to do in this case? So I just want to, let's open this in the text editor. I just grab this and just place it to here where I have my terminal being opened. Okay, and what I need to do here, so just to give you an idea of desktop Tetris. Yeah, here we are. So here I'm going to be creating a new image. So if I just say like nasm -f bin and tetros.asm and -output tetros.image, it would work. However, the size is still gonna be 512 bytes long. Okay, but before actually considering anything, let's try to figure out what exactly goes wrong here, and what in particular are we going to achieve at the very end. So if I also I already have this being opened in the terminal. So on Linux, I have command xxd, which allows to see the binary, to inspect the binary files. And if I just say tetros.emg, I see that we have exactly 512 bytes. So this is the boot signature here, and this is it. So we don't have anything else, and that's a bit of an issue. Okay, so how to deal with this? There are at least two ways that I can say, kind of like out of the box, of what to do. So we can either use some external tool like DD, let's say on Linux. But I just want to demonstrate one very handy very handy tool that doesn't need anything else but nasm on its own. And as far as we really need to use nasm anyway, this is a very nice technique to consider if we want to create a bootable floppy image. So what this line does, it literally fills the bytes until we have exactly the size of bytes being available on the floppy drive. And here, I just want to put it right over in here. And also, so here we set up the boot signature. All the boot games has these lines, so just grab all of this stuff. And as far as I have no idea how to turn on the debug mode here, I just don't really want to get bothered with this. I just make it like this. Okay, and now if I assemble this again, and if I inspect this in the binary, I shouldn't, I'm sorry, no, I don't want to. I just want to inspect this TetrOS EMG. Okay, I don't need sudo here, but anyway. So now, as you can see, we have really lots of 0 bytes being added, and now this is a valid bootable floppy image. So if you write this to a real floppy and try to run from this, it's gonna be working, okay? But we don't have floppy nowadays, obviously. So we're gonna be writing this directly to USB flash drive. But before that, there is a good test. So if thing works in emulator, then probably it would be working on real hardware. However, if thing doesn't work on an emulator, then most likely it's not going to be working on the real hardware as well. So emulators are usually more user-friendly things. So here is the image that we'll now try to boot using our online emulator. So I could have used QEMU as well. I can probably show you that as well. If only I could remember the, yeah, hold on a sec. If I just, QEMU, I just don't remember the command. x8664 minus FDA floppy drive and TetrOS image. I don't remember if I did specify. Oh, okay guys, I'm sorry, just let me very quickly see the command there. I just don't really remember it by heart. Okay, so the command is, okay, QEMU system. This is the command. Okay, and yeah, let's first see this on a Linux emulator. So I want tetros.image. Okay, and here we go. So we can play Tetris in the emulator. But if you don't have an emulator, it's not a big deal. You don't even need to install the emulator, because once you have a working image, or sometimes it happens that the developers are providing the working image on their own, and developers sometimes do care about that their image is going to be running in the certain online emulator without a problem. So sometimes you might be lucky and being able to run this without recompiling or doing anything. So now I'm using this tetros.image here and going to start emulation, and now this should be working properly. Okay, is this still sorry guys, well, I have no idea what's, no, it's just some, it's some old stuff that we don't want. So this is just some old stuff. Let's go to, yeah, that was not the case. So let's go, yeah, that was just run, horribly run. So that wasn't the right file. So this is the right file, and yeah, the one that we've just run via QEMU. And here we go. It's a little bit strange that here we don't actually, oh yeah, we do have colors, I'm sorry. I thought that we didn't have colors, but we do, which is good. So this is pretty it. Okay, so we can play Tetris here as well. So now, if we can play Tetris here, then most likely we're gonna be able to run it on a real hardware as well. But one little more thing that I want to check before anything else, and regardless of the result, we'll still go and write this to the flash drive. But anyway, flash drive is treated to be like a hard disk drive, especially when it comes to reading the sectors or from the flash drive, or writing the sectors to the flash drive in case, let's say, if we want to work with the files being stored in the image, either in the bootloader to load somewhat an operating system like, or if we do load somewhere, as let's say we have a bootable text editor and we want to just save the file to the image, in that case it matters whether we're writing to the floppy or to the hard drive. And flash drive is treated to be a hard drive, and there are some tricks to make it work, because it wasn't really that trivial and took me quite a few years to figure out how it works. I mean, like, I didn't succeed once, and then I just didn't do this for a few years. And today, surprisingly, I finally found a way how to read and write sectors on USB flash, and that was probably one of the happiest days of my programming life. Okay, so let's try to run this as the hard drive, and in theory, this would be something closer to what we're going to be doing on the real hardware. Okay, and yeah, here we go. So it works as on a hard, like as if this been running from the hard drive as well. Perfect. Okay, guys. So now we need a flash drive. No product placement. This flash drive is pretty old. Okay, and I just plug it in now. Well, before I plug it in, just to give you an idea that. So let's go back to the terminal. So if I say sudo sudo fdisk -l, I don't have my flash USB flash here, but once I plug it in, okay, and run the command again, okay, so here it is. And another thing to consider, so flash, the USB flash drive that we're supposed to be working with might be whatever. It might be a bootable flash or not bootable, or containing some data. It might be FAT32, Linux ext4, or whatever file system type format. We don't really care about what is there, and the way how I'm supposed to be is how I'm going to be preparing this this very flash drive before we're going to be writing this our image onto it is the following. So all we need is the first 1.4 megabytes of the information, and we don't really care what would be there in the rest of our flash drive. So well, you could have used some tools to work with them, but I've been trying those, and even on Linux it doesn't always result in creating actually a bootable flash. So I prefer doing everything by hand, and especially this helps understanding of how this entire booting process is working. So let's use, well, actually this flash drive I'm currently having here, it's not even recognized by the operating system because it is bootable already, and I've messed up everything there. But just to give you an idea, so if I say like sudo, and on Linux everything is a file, so I can treat so in order to see what is there, I can say xxd dev sdb, and because I have this this is the address for my, this is the path for my USB drive, and hit enter, and now it goes for all the megabytes it has. It's quite pretty a lot, all the zeros so far, but then we have some garbage. So this is some data that was there before. I could have formatted the entire USB, but that's not really necessarily needed. So just drop right over in here. And also what I want to show, so currently it is actually a bootable flash, and it actually is already containing the game that we're supposed to be running, and here is the boot signature. But let's assume that it's malformed or whatever here. So what I want to do first is to initialize zeros from the very first byte and up to 1.4 megabytes. So how can I do that? That's how I'm going to be doing it. So I'm using the dd command here. So just copy the command. Don't really remember it by heart yet. And paste and run. And now let's have a look at what we got. Let's clear first, and here's what we got. Okay, No, it's not what we got. Sorry guys. Dev 0, floppy image. Oh, yeah, sorry guys, I need to specify my, yeah, just grab the wrong one. So yeah, actually the output file is not the floppy image, but my dev sdb. Okay, and yeah, now it's permission denied because I want to be the super user here. Okay, and clear, and yeah, so let's have a look. And now the flash is really virgin here, so crystal clear, nothing what we don't want. So, and the first 1.4 megabytes are all zeros. Doesn't matter what we have later on, but this first are all zeros. And now, what is the boot sector? So the boot sector are the very first 512 bytes on the storage device. So starting from here and ending up somewhere over in here. Okay. So now we need to write our data to this storage, basically. Okay. And a dd command would help me to do this as well. So we have this. Oops, sorry. Desktop. So here is the image that we need to write right over in here. So here is how am I doing this. So now the input file would be not the zeros, but my Tetris image. So tetris.image, and the output would be the same. So this count stands for how many, I'm not sure, sectors apparently we have, and this is the size of a sector. You might omit this potentially, probably would be working as well, but just to make everything clear, I keep this count and bytes parameters. So let's run it. Okay, TetrOS. Sorry, this is called TetrOS. Stands for operating system, I believe. Okay, now let's clear, and now let's see. Again, like sudo xdd, and now we should write the bytes back. Okay, now we have our bytes, and the bytes end up with this kind of boot signature. All right, so from now on, we are ready to, we can now just unplug the USB drive. Okay, here it is. Here is my USB drive, and I'll just turn on the camera, and we'll show you how am I gonna be running this on a real device. So stay tuned. Here is the flash drive that, oh my god, I just crashed the label that I had there. Okay, so here is the flash drive that we're supposed to be working with, and I just plugged this into the USB port. Okay, oh man. All right, so I'm running the laptop. This is the x86 Asus laptop, a very old one I had, and assuming that probably you're not, you don't have a proper root ordering, I'll just show you what I'm doing in my BIOS in particular. So, well, I believe that in your BIOS this would be a bit different. Because BIOSes are different from one model to another, but the overall idea is the same. So if we go to the boot section, so here we have the hard drive BBS priorities, and this 0000 is my USB drive. So in your case, it might be recognized like the brand of the USB drive or somewhere else. Anyway, you can try to have a look to inspect the boot options if you don't have this drive being plugged into your computer, and then you plug in and you see this new entry. So this should be the first priority, and here it should, in my case it goes automatically, but here it should be the priority as well. So I just discard changes and exit. And in my case, it's already kind of like running Tetris. And here we can actually play Tetris. So let's try to play a little bit and see how it works. Well, probably colors are not very exciting. Trust me that there are different colors. Okay, that's probably should be seen as well. So, oh man, I didn't mean this. Okay. Yeah, no, it's not really that great position what I have now. But let's try to do at least something. It's a bit unfortunate that the rotation goes counterclockwise, and I didn't really used to that sort of a thing. I used the clockwise rotation. So it's already a good reason to create your own Tetris, by the way, which I am going to do in the near future. And not only the Tetris, but potentially some more games. And maybe we will even go for coding a simple, I don't want to call this operating system because it's not going to be really the operating system, but something that would allow us to run several games without a need to make all of these steps that we've been through in this video. So you imagine, guys, how cool it would be to have one image where you would be having several games, right? So you don't need to create a simple kind of like drive. So you don't need to write the drive every time you want to play a different game. So it's really cool to have just a single image with all the boot games that you want to play, and you can then just start your computer and play those games. The only thing that you will need in that case is some sort of a user input stuff to make it possible for a user to pick up the proper game that you want to play. And well, this might be treated as an operating system at some point, but yeah, so no matter how to call it, yeah, and anyway, I'm just lost here. So a bit of an issue, like in the boot games, we just stuck here, and in order to play one more time, I just need to press Control Delete, Control Alt Delete, and in that case, I would have my game being restarted. So in the next video, we're gonna be trying to we'll actually write a bootloader, and we'll learn how to properly place the game onto the floppy image that we'll later write to the flash drive. And the idea is how can we read this boot sector games without actually implementing a file system. So later on, we would be able just to read a single sector from our image and load it to memory, and then jump there. So literally adjusting our instruction pointer, which is stored within the code segment register, and then we'll be able to play a game. And after the game might be modified a little bit, so let's say if escape is pressed or something, that we can just kind of like escape, like jump back to the selector app, kind of like. And in that case, it would be really cool to switch between different games. But meanwhile, all of these games are actually still can run as the boot sector games. And the exact scenario I've been up with, I was actually playing around with loading the games. So let's say you write a boot sector, which loads the app that allows you to run the code, run the games from the boot sector, and then it allows you to from that app will load a game back to the boot sector, because it might happen that the game relies on the certain place where it should be loaded. However, the bootstrap games in some cases might be loaded not exactly to the exact place where the boot sector loads in the random access memory. But again, like, so I'm gonna be covering this in great details in the further tutorials. And for now, this is it from my side, guys. I hope you've enjoyed this tutorial. So thanks for watching. Until the next time, and take care.